Today we'll be looking at matrices. Um, okay, when you talk about matrix simply means the arrangement of elements or the arrangement of numbers rather in rows and columns, or simply means the arrangement of numbers in an array. Now, matrices are normally being represented with capital letter, while each element are being represented with small letters or numbers. Examples of matrices are given as A equals to A, B, C, D. So you can see from the box, this A is the matrix. You can see it is written in a capital letter, while all these are the elements or members of the matrix. So you can clearly see that the elements of the matrix are being represented in small letters, while the matrix itself is always in a capital letter. Please, all these things are very important about a matrix. We have some terminologies or some terms we need to note in matrices, or rather, it's what we call, can call them terminologies or subtopics, or the things we are going to discuss in matrix. So one of those things is one, order of the matrix. Two, we have definition of some special matrices. Three, we are going to discuss addition and subtraction of matrices. And four, I'm going to be looking at scalar multiplication of matrices. And five, we'll talk about multiplication of matrices. And then six, we'll look at, after multiplication of matrices, that's equality of matrices. And then from here, we look at determinants of a matrix. And then after that, we talk about minor of a matrix. And then after that, we're going to look at cofactor of a matrix. Then we look at adjoint of a matrix. And then from here, we look at inverse of a matrix. Then here, we talk about Cramer's rule. You can probably look at the Gaussian elimination, rule. Then, lastly, we talk about the matrix inversion method. Let us say the matrix inversion. Wow. So all these are what we'll be looking at in matrices. Left I forgot. I think we still have two left. I think we also talk about order of a matrix. That is number 15. Then lastly, we look at transpose of a matrix. And please note, in matrices, we make use of a special bracket, which I call the matrix bracket. Of course, in mathematics generally, like I've said before now, we have various types of matrix, various types of brackets. We have this, we have this, we have this. Of course, this one is used when you are discussing set theory or probability, and this one is your normal bracket that we all know. But in matrices, this is the bracket we normally make use of. This particular bracket is what we use when it comes to matrices. So we'll start by looking at the order of a matrix. So we'll look at the order of a matrix. And please, before we continue, matrix is the singular form of matrices. That is, when you have a matrix, you call it matrix, of course. And when you have more than one matrix, it's called matrices. Please take note of that. It is also very important. So let's look at the order of a matrix quickly. Now, the order of a matrix is always of the form m by n. Okay? This is how it's been written, but you pronounce it as m by n. So that is how the order of a matrix is. Your m simply means the number of rows, while your n simply means the number of columns. Of course, when you talk about rows and columns, for example, when you have A equals something like this, let's say you have 4, 2, 3, minus 1 as this. Now, this is the matrix, of course, and all these numbers, they represent the elements or members of this particular matrix A. Can we get that? So now, when you talk about rows and columns, this way is what we refer to as row, while down this way is referred to as column, which means in this matrix we have row 1 and row 2. Then we also have column 1 and column 2 this way. So that is how to identify a row and a column from any given matrix. But what we are looking at now is order of a matrix, just that you need to understand the concept of rows and column before we discuss this in detail. So now, I told you that the order of a matrix is of this form, m by n, where your n is the number of rows and n is the number of columns. Alright, so now, for instance, let's take samples under this. You want that much? Find the order. Find the order of the following matrices. Find the order of the following matrices. You have 1. Let's say you have matrix A equals 2, 4, let's say 6, 8. And let's say we have matrix B equals 2, 3, 1, 4 minus 1, 3, 6, 0, 8. And let's say we have another example. So let's say we have another sample 3. Let's say matrix C is equals 1, 2, 0. Now, solution to this. Now, what we are told to do here is to find the order of the following matrices. Now, to get the order of the matrix is very simple. So please listen and try to understand one or two from here. So now, let's look at the first one. Number 1, here we have A equals, of course, 2, 4, 6, 8. For for instance. So to get the order of this matrix, now the order of matrix A equals 2 by 2. Now, why is it 2 by 2? It is 2 by 2 because the matrix A contains 2 rows and 2 columns. And please, when you want to write out the order of a matrix, always write out the rows before the number of columns. Very, very important. Alright, so you can see this is 2 by 2. Please, 2 by 2, 2 by 2. You don't write it like this, it's wrong. This is the right way of putting down the order of a matrix, please. Now, for the second one, we have matrix B to be equals to, I think we have 2, 4, 6. We have 3 minus 1, of course, 0. We have 1, 3, 8. So the order now, the order of matrix B is equal to, of course, when you look at this now, this is row 1, row 2, row 3. So we have 3 rows by, we have column 1, column 2, column 3. So we have 3 by 3. So this particular matrix is a what? A 3 by 3 matrix because it has a 3 row and what? 3 columns. So that is the order of this particular matrix B. And of course, for this number 3, that is C equals 1, 2, 0. And from here, we have the order of matrix C now, and it equals to, of course, this is row 1, that is just 1 row, by 1, 2, 3, you can see. So we have 3 columns there. So this is a 1 by 3 matrix. So the order of this matrix is 1 by 3. So to me, if you are given any matrix, I think it's very simple for you to find the order of any given matrix. Yes, it's very simple. The only thing you need to understand is the concept of M by N, where your M is the number of rows, and of course, your N is the number of columns. So with this, I think we have come to the end of the order of a matrix. So I will briefly dash into definition of some special matrices. Meanwhile, I will list some of the special matrices, then I will define them orally. So you listen to my voice so that you can understand it from there. I may not write them out, but I'm going to list them now, and then I explain orally. So we have the first special matrix to be what we call row matrix. Then secondly, we have what we call the column matrix. And thirdly, it's what we call the node matrix. And the first type of matrix is what referred to as a unit matrix. The unit matrix, which we are also called an identity matrix. And then so we have number 5 types of matrix to be a diagonal matrix. And number 6, we have what we call a square matrix. And then number 7, we have what we call a rectangular matrix. Then number 8, we have what we call the lower triangular matrix. And of of course, number 9, we have what we call the upper triangular matrix. Okay, so I think those are some of the various types of matrix we have. So now I will be explaining them one after the other orally. So for the first one, the row matrix. Now a matrix is said to be a row matrix if it contains one row. So any matrix that contains a row is referred to as a row matrix. For instance, please look at this place. For instance, A equals 1, 2, 0. So you can see that this matrix only has a row. So for that reason, this particular matrix A is referred to as a row matrix. So it's a very good example of a row matrix. Then the column matrix, of course. As the name implies, a matrix is said to be a column matrix if it contains only one row. For instance, let's say you have matrix B equals 1, 2, 0 this way. So you can see that this particular matrix has, of course, it has 1, 2, 3 rows, but just one column. So we are not looking at the rows, rather we are looking at the columns. So since it contains one column, it is referred to as a good example of the column matrix. So that's the meaning of the column matrix. And of course, the next one, the null matrix. The null matrix. So a matrix is said to be a null matrix if all its elements are equal to 0. And it is normally denoted as letter O. For instance, letter O equals 0, 0, 0, 0, or letter O equals 0, 0, 0, 0, 0, 0, 0, 0, 0. So you can call this one a 2 by 2 null matrix, while this one is called a 3 by 3 null matrix. Please, all these matrices are special. And then for the unit matrix, or the identity matrix. Now, a matrix is said to be an identity matrix if all its elements are 0, except the element in the leading diagonal, which must be equal to 1. It is normally denoted as letter I. For instance, matrix I equals 1, 0, 0, 1, or matrix I equals 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, this one is referred to as the leading or the principal diagonal. Here, this one is referred to as the leading or the principal diagonal. So you can see that the elements in the principal or leading diagonal are equals to what? 1. And every other element around the matrix are equals to what? 0. So when you see a matrix like this, it is referred to as what now? A unit matrix or an identity matrix. So you can call this one a 2 by 2 unit matrix, and this one can be called a 3 by 3 identity matrix. So that's the meaning of the unit matrix. Then for the diagonal matrix, of course, as the name implies, a matrix is said to be a diagonal matrix if all its elements are equal to 0, except the element in the leading diagonal, which can assume or which can take any value. For instance, matrix T equals 1, 0, 0, 0, 2, 0, 0, 0, T. You can see that this is the element in the principal diagonal. They are taking values randomly. Unlike the unit matrix whereby the values in the principal diagonal must be 1. But here, the values in the principal diagonal can be any number, any non-zero number. But every other element in the matrix must be equal to 0. So that's the meaning of the diagonal matrix. And of course, the square matrix. A matrix is said to be a square matrix if the number of rows is equal to the number of columns. Any matrix that has or that have the same number of rows and columns is referred to as a square matrix. And then, of course, for instance, you can say this now. For instance, let us use this as a case study. This one now is a square matrix because the number of rows here we have 2. The number of columns are also what? 2. So it's a very good example of a square matrix. These two is a good example of a square matrix because we have three rows here and three columns. So that's, I think that's the meaning of the square matrix. And for the rectangular matrix, a matrix is said to be a rectangular matrix if the number of rows are different from the number of columns. For instance, this previous sample, you see that this one has just one row and three columns. Of course, you know that the number of rows there are different from the number of columns. So such matrices are referred to as a rectangular matrix. And then of course, the lower triangular matrix and the upper triangular matrix, they are opposite of each other. Now, what's the meaning of lower triangular matrix? Now, a matrix is said to be a lower triangular matrix if all its elements above the principal diagonal are equal to 0. Why the matrix is said to be an upper triangular matrix if all its elements below the principal diagonal are equal to 0. Let's give a very suitable example of these two, which are the lower and the upper triangular matrix, for better understanding. Now, a matrix of this nature, L, equals, I think, 1, 0, 0, 3, 4, 0, 6, 1, 2. You see that this is the principal diagonal here. Now, you see that all the elements above the matrices, or above this matrix rather, is what? They are 0. So since they are 0 now, it means that there is a triangular this thing here. See, look at the triangle. There's a triangular matrix formed below. That is why it is called the lower triangular matrix. And then when you have a matrix, for instance, U equals to something like this, 1, 3, 6, of course, 0, 4, 1, and let's say 0, 0, 2, for instance. See that this is the principal diagonal here now. See that all the elements below the principal diagonal are equal to 0. I don't know if you are getting my point now. So from here, you see that there is a triangle formed up this way. Look at those elements, they form a triangle like this. So that is why you have it to be what? Upper triangular matrix. So this is what we refer to as lower and upper triangular matrix. Although for higher level, we also have other types of matrix, which is what we call the Hermitian matrix, the skew Hermitian matrix, the symmetric matrix, and the skew symmetric matrix. But those ones are too high for our level. I think today we'll stop here for this class. Now, in our subsequent classes, we are going to talk about the other techniques used in matrices. Thank you for watching my video, and please do subscribe and like and share my video. Thank you.